All right, let's look at some practical uses of differential equations. So in the real world, as they say. So we've got a tank which contains 30 litres of a solution of a chemical in water. The concentration is reduced by running pure water into the tank, and it's coming in at 1 litre per minute, and then the solution runs out of the tank at 2 litres per minute. The tank at any point in time will contain X litres of chemical after we start the dilution. Show that dx to t is minus 2x on 30 minus t. All right, so what do we know? We know every minute the volume of the tank reduces by 1 litre. 1 litre going in, 2 litres going out. Okay. Thus, in t minutes, the volume will be 30 minus t litres. Okay, 1 litre every minute. Now, so at any point in time, the fraction of solution that is in the chemical will be x, because x represented number of litres at time t, divided by 30 minus t. So x out of the number of litres we have in the tank. We know the solution is escaping at 2 litres per minute, so the rate of flow will be 2 times that rate, but it's decreasing, so we know it's negative. So we end up with our rate of negative 2x on 30 minus t. So find the fraction still in the tank after 20 minutes. So let's say the original volume, we don't know what the original volume was, so we'll just call it V. We have now worked out that dx to t is equal to minus 2x on 30 minus t, or if we hadn't worked it out, conveniently they gave it to us, so at least we can keep going with the problem. So let's create our differential equation. Dx over 2x will equal minus the t on 30 minus t. We said at 0 times 0, we're calling the volume V, and we want to link t and x. So we get half log x, and on the right hand side log of 30 minus t. So x on v and 30 minus t on 30. There's our formula for x. We want to know when t equals 20, so sub it in, we get v on 9. So 1/9 of the original amount. So I don't know what v is, but it said find the fraction. It didn't actually say find the volume. Okay, population of foxes on an island. So it's the classic logistic equation there. Y, 1 minus y, times 0. The population of foxes is estimated to be 1/4 of the island's carrying capacity. It's a different way of solving this logistic equation to what we looked at yesterday. So they want us to use the substitution y equals 1 on 1 minus w to show that it simply just becomes a classic exponential growth and decay question. So it becomes w dt is equal to minus w. Let's see what happens. So we're using the substitution y equals 1 on 1 minus w. Therefore, dy dt, well, I can't differentiate the right hand side with respect to t, but I can with respect to w. So I'll get 1 on 1 minus w squared times the w dt. We know dy dt is y 1 minus y. But, again, we're substituting in for y. So y 1 minus y becomes 1 on 1 minus w times 1 minus 1 on w. All I've got to do now is make the w dt the subject of this, and hopefully we'll end up with negative w. So multiply both sides by 1 minus w squared, and yes indeed, it all cancels down to be the w dt is minus w. So using that solution, find the solution of the logistic equation for y that satisfies the initial conditions. Okay, so the initial conditions, remember, was when t equals 0, y was 1/4 of the island's carrying capacity. Well, I want to know what w is at that point. So 1/4, remember, y is 1 on 1 minus w, so w would be negative 3. That'll be the initial condition for w. Okay, there it is. The w to t is minus w. I say it's our classic exponential growth and decay. So it'll just become minus 3e to the minus t. So therefore there's y. Remember, y is, y is 1 on 1 minus w. Yeah. Well, we just found w was minus 3e to the minus t. So it's an interesting way of approaching that problem. But there's more. How long will it take for the fox population to reach 3/4 of the island's carrying capacity? Now we're just solving this exponential equation. When is it 3/4? Playing around with it, and we end up with, there we go, 2.19722222222222222, depending how accurate you want it. 2. You can have another one, 2. So about 2.2 years. Okay, you rumour spreaders. A rumour is spreading amongst the 1,000. I didn't use 1,200, which is closer to our school, but 1,000 is a bit nicer number to work with. So a rumour is spreading amongst 1,000 students in a school at a rate proportional to those that have heard it, and those who have not heard it. So it's proportional to both x and 1,000 minus x. As time progresses, people care less about the rumour, so the proportion rate is not constant. In fact, it ends up being dx to t is x times 1,000 minus x, there's the proportion, times some constant k, and in this case divided by t plus 1. So initially, one student, as all good rumours are, starts with one student. One student starts spreading the rumour. After 1 hour, 50 students have heard the rumour. How many students have heard the rumour after 3 hours? There's our differential equation. Separate the variables on that. This time I did do the limits. So 1 to 50 dx on x 1,000 minus x is k 0 to 1. We can now work out what that k is. Let's solve it. Using a bit of partial fractions there, we get 1 on x, 1 on 1,000 minus x. And there we go. There's the constant in all its glory. The log of 999 over 19 over 1,000 log 2. I'd still just keep k in my calculations, I think. All right, we want to know after 3 hours. Again, we'll do some integration. Is log 999x over 1,000 minus x, right, is equal to some constant value. See on the right there, all of that is some constant value which I just haven't evaluated yet. Because we're subbing in from 0 to 3. It'll come up with a number. So rather than me having to write down all those things, I'm just saying, okay, well, I'll work that out later. Okay, so that constant c actually turns out to be 1,000 times the k that we worked out, times the log of 4. A bit of cancelling happens there. We end up with 2 log 999 on 19. We're trying to find what x is. There we go. So x will be 1,000 e to the power of c. Remember, c is that number we worked out before. Over 999 plus e to the c. We end up with 734. So 734 students have now heard the rumour. All starting with one person. Because 735 haven't heard the rumour yet. So they might be halfway through being told, and there's the 0.5. They don't know the actual rumour yet. All right.